Good afternoon, ladies and gentlemen. Welcome to AI Creative AI Workshop by Apra Labs at IISc Bangalore. We are going to start. I welcome Kashyap, who is going to deliver the workshop. Uh, can we have a round of applause for Kashyap? And there are other people also, for them also. Let me hand over the dais to Kashyap, and from then on, we will take up.
Does this mic work or does it doesn't work? Okay, thanks. Hi everyone. Welcome to Apra Labs Creative AI Workshop. Thank you for waiting. I'm Kashyap Joyce. I'm a senior data scientist here at Apra Labs. I've been working here for the last 6 years, and I have total 8 years of experience in data science. So what do we do at Apra Labs? This is our vision to create value and delight our customers through the most innovative products and services. And today you will get a taste of what we do almost every day at Apra Labs. So before I go ahead, I want to see the energy level over here. So everybody has to say AI. Let's go. 3, 2, 1. AI. 3, 2, 1. AI. Okay, now our computers are going to take over. It's okay. So this is our value proposition. We work somewhere, in the midst of all of this. So basically, we work in video and cloud technology, video surveillance. Then we have embedded video and cloud. So this is, edge to cloud solutions, hybrid analytics. There's like access control, biometrics, all of this stuff. And then we are very proficient with NVIDIA Jetson devices. So if you come and visit our booth, we also have a booth here at Pravega. You'll see, some of the Jetson devices that we use. And basically, our main focus is computer vision, embedded engineering, and cloud. So this is our relation with IISc and, Apra Labs. This was us last year at the booth. So you can see me and then Jasha, so a few familiar faces. So we had a few demos going on, and a lot of fun is happening this time also, so please do visit. So this is me actually. So last year I was on a different stage. I was here at Pravega and I played with my band, and today I'm on this stage, so it's nice to be here. But I also have a creative side. I play bass guitar for a band called Spaces All We Have, and I have some opinions on the ethics of all of this, but we'll get to that later. So another thing about, Apra Labs and IISc, we also, involve and provide the ECE Women Travel Grant. This is Memory. She presented her amazing work at the European Geoscience Assembly 2023. And this is basically a quote from our founder, Akhil Kumar. And our main idea here is to, promote women. Usually they don't have either the family support or they don't have the backing to go and present their papers in international conferences. So yeah, so this is something that we do, which is also very closely linked to our relation with Apra Labs and IISc. And then all the work that we do is all of this. So we work on cameras all the way from small like needle size, you can see that, or right on the top, all the way to big cameras that can cover huge surveillance areas. And this is again the edge devices that we work with, NVIDIA Jetson. And on the right you see an example of some of the computer vision work that we do. Can everybody hear me? I'm just checking once. It's all fine? Okay, great. So this is also part of our meetup. We've been hosting meetups at Apra Labs in our office since December 2022. Coincidentally, this is the 10th edition of our meetup. So Welcome everyone. Thank you for coming. It's a great turnout. And we've covered a lot of topics, healthcare apps, embedded systems, generative AI, Web3 and more. And, I hope to see more of your faces in our office next time we're going to host a meetup. And hope you like what we show you today here. So now I'm going to hand it over to my colleague Abhinav. He's going to show us a small demo. You'll get to play this game if you visit our booth, but he's going to quickly show you some of the fun stuff that we do with AI.
Hi all, I am Abhinav. Can you just say if you can hear me? Yeah, am I audible? No? No? Hello, am I audible now? Yeah? Okay. So this is one of our demo which we are showcasing in our booth. You can visit us. If you manage to get into the leaderboard, you might get some goodies. Not you might, but you will. So we'll start with the demo, what exactly it is. So yes, so in this demo, we are showcasing the how we can utilize the PoseNet model, which basically estimates your pose, the human body pose, given an input image, right? So here our source is video, and then it is passing it frame by frame, and then estimating my position. Fundamentally, it was designed to this detect the skeleton of the body, but then the name changed, and so as I'm referring, it is PoseNet and estimation of pose. So basically, it tries to detect the 17 key points. Those are our joints and I guess 12 joints. And apart from that, two eyes, nose, lip, and two of my ears. In our demo, we are using the spinal cord, as you can see. And after that, it gets two initial marker from spinal cord. Those are my elbows. And after that, it used those elbow markers to estimate my whole hand. And then we have created this circle. You can see this is my estimated palm. And this we are using to bounce back the ball. The idea is to uh, yeah, the idea is to keep the balls in air for maximum number of time, and you can drop up to 5 balls. So moving from demo, I want to get dig more into the PoseNet model. Can we have the slides? offset vectors are nothing. It seems to be confusing, but exactly these are the XY coordinates, nothing else. If you go through the definition of it, it might sound little confusing, but if you try to apply it on your computer and see what the results are, it is just an XY coordinate, nothing else. And after that, you can scale down your output using output stride. There is a parameter, output stride, which is basically how much you want to scale down the output resolution based on a given input image. And one more advantage of PoseNet is it is it is size invariant, so it doesn't matter what is the width and height of your image is. It will do the processing on the image size which you have given. Nothing will change. You don't have to rescale, resize anything. This is the pipeline of how this model works. Next, as I was saying, there is something called output stride. This is the main part which happens in between. So given an input image, I will I have to select an output stride. So it's just a number. The higher the number, the lower will be the resolution of the output, right? So you can see there's some mathematics involved to calculate what is the matrix size. If the stride is 32, it will be a matrix of 32 cross 32 across the 17 key points. Similarly for 16 and 8, and it comes off with a trade-off. That is, if you have a smaller output stride, your computation will be slower, but your accuracy will be more, just like any other model we have in computer visions. Yeah, that is pretty much it. Which is in PoseNet. There's nothing more. Yeah, this offset vector which I was selling. So suppose this there this is my whole heat map, and every point at heat map has a corresponding confidence score for that particular key point. Suppose this is a heat map for my nose, right? So every point here has a confidence score for my nose. The confidence score is the probability that this particular point, the estimation of this particular point is correct, to the key point which I'm trying to estimate. So suppose for this it would be 0, 0, 0, but for those points which are near my nose, the confidence score might be more than 0 0.9, 0 0.91, and it would be varying. Then the offset vector, so now I will be zooming that, and we get this. So these are our points, and we get an offset vector. Okay, so all these points have some corresponding confidence score, and then these vectors are nothing but just the xy coordinates to the point which is to the point where the confidence score is the highest. This way we get a heat map and corresponding offset vector. I think you might have got confused with offset vector. To simply explain, heat map is a matrix with a confidence score for the estimation, and offset vector is the corresponding xy coordinate matrix. That's it, nothing new, nothing more. Thanks. Next, we'll be moving with our another demo, that is neural nebula, and would like to call Mradul for this.
So I am Radul. I've been working at Apra Labs for last 5 years. Uh, Currently, I'm doing a lot of work in healthcare domain, again, which is specific to computer vision, and I've done a lot of ML work as well. So what we have here is another demo that we have at our booth. Uh, I would like all of you to visit our booth. It's more fun than it looks here. The Technotalks demo is actually very fun. Just try it out. Uh, the Neural Nebula demo, we couldn't get a live demo for you. I apologize for that. We were bound by some restrictions. So this demo requires a lot of GPU VRAM, and we were limited because we wanted the demo to work there at the booth. So what I have here is a recording of it. Thanks. So let's just see that once. So Manoj is standing there. He is one of my colleagues. And we click on change background. This is sort of the spicified explanation of what we are doing behind the scenes. So we detect human, we segment them out, and we generate some artificial content that we will apply. So the prompt that you see at the top, it says space shuttle. So you can see that the background sort of looks like a space shuttle because it's, after all, it's generative AI, and we are getting the first output of that model. So the model is in a way that you can generate multiple outputs, and the outputs refine as we take the second, third, and so on. But since we are bound by VRAM on our hardware, we are taking the first output. There is another button there. I'm sorry I couldn't talk about it earlier. So what that does is it changes the uniform. Uh, I think is, yeah. So let me just go to that part. Okay, so I think that is not there in this, but that also works. So basically, what will happen is that his T-shirt will get uh, it will get changed to a spacesuit. So in this case, so I'm sorry again, but please visit our booth. We'll give you a nice demo there. So what is happening? So what is happening is, so we built this small application within last few days, and how it works is that we capture some image, we resize it, we identify human figures, we segment the human figures. So basically, we get a mask. So the a part of the image where the model detects humans will be white. So in pixels, talking in terms of pixels, it will be 255 or 1, and the rest of the image will be 0 or completely black. And then we generate some content using the generative AI model. I will talk about it in detail a little bit. And for background and for dress, depending on which use case it is. And we apply the segmented human figure on that. And the final image output that is there in the application, it is being rendered using this module that we have, this framework that we have developed in-house. It's called Apra Pipes. I will talk a little bit about it. I see that it is mentioned there in two boxes. Uh, so just to give little more idea, don't think you are being shortchanged here, because in the workshop we will be actually trying to go through this exact pipeline. So this pipeline involves a lot of AI models, and that is our core of workshop here. So we will try to showcase to you how object image segmentation, image detection, and generative AI works. So we will go through all this. So this is just a very rough overview for you. Talking about Apra Pipe, so it's a pipeline framework. Uh, the idea is that if you want to develop any video, image, or AI ML application, you can use that. It's open source. It's based on a lot of things that we have learned over 16 years in the organization. It's highly customizable. It's there across platforms, and it supports multiple frameworks. So so the idea is that even if you come up with a nice AI model and that is working great, how do you use it in the applications? And that's a challenge most of the time, and it's a bigger challenge than you think. So the framework solves that as well, apart from doing a lot of other things. But if I just talk about the basics, so there is a source, transform, and sync. So we have three types of modules in the framework. So source is basically something that gives frame, for example, your webcam, and transform can be as simple as, it can be an AI model that does some processing on the source image, or it can be as simple as resize. And ultimately you have a sync, which can be a render, which can be a rendering module. It can be something like RTSP streaming, where you can stream it and view it somewhere else. So these are like, and there can be multiple transforms. These are just the basic building blocks. Uh, Again, the same thing there, just little bit terms. Module, I already talked about it. Pins are basically input output. Metadata is just data about data. So for example, the image that you flows through the pipeline has some resolution that can be metadata. Or what is the type? Is it RGB? Is it RGBD? Is it YUV? So all that frame container is basically what happens is when frames are flowing through the pipeline, you need to send multiple frames. So you need some packaging for the multiple frames that you're sending, and you send them as units across the modules. So that's what frame container is about. Queue, I hope you guys know, it's just first in, first out, because ultimately you are running the pipeline at some FPS and frames are flowing through. So you need to process them in the manner they arrive. So queue is just to ensure that happens. Pipeline is just the overall pipeline. Uh, this I already talked about. So source can be a camera, file reader, MP4 reader, can be RTSP stream input. Transform again, it can be all these things that you see there. Uh, Again, sync can be video writer, can be file writer, it can be network sync. So that's all there on this. I'll be back with the same discussion. Currently, Kashyap will be back for the generative AI discussion. I know you guys are waiting for this, so I'll just give it to him.
Okay, I'm back. So there's a running joke. How many engineers does it take to change an HDMI cable and a mic? Who knows the answer? Okay, this is a joke. Anyway, so getting into generative AI. So what you see here is a diagram, that's pretty descriptive of what most people would have thought of AI. I mean, before, ChatGPT's blow into our worlds. On the left is this discriminative AI. Basically, you're training some sort of classification model. You want to know red versus blue or dog versus cat. And then so what you learn here is probability of y given x. So that's basically this line, right? You're trying to find the best line that can divide these two groups or these two classes. Whereas in the case of generative AI, what you're trying to do is you're trying to learn the distribution. So you're actually trying to learn, P of x. So you're trying to learn this ellipse that you see, right? The red color and the blue color. And why you want to learn that? You want to learn that because you can sample from that and generate similar samples from that space. Okay, another concept that is fundamental to understanding why ChatGPT works so well and all these new transformer models, LLM large language models work so well, is basically this thing called transfer learning. So if you see AI, I mean, we have been doing this research for quite some time, right? We as in humankind, and it's not like the change what you see now that hasn't happened over 1 year. It's happened over many years, and transfer learning came somewhere in between, around where ImageNet was introduced to the world. So ImageNet is a big data set of images, and then after that you saw a lot of convolutional neural networks coming in, and you saw a lot of models coming in, and all of them were basically kind of using this concept where you train your base model on a large on a large data set, and then you kind of just shift the task basically, right? So on the left what you see is we had these very individual models. Everybody would try to collect their own very niche data set. They would try to train their own model to solve task A, task B, task uh, Z. And now what you have is you have this, this sort of foundational model that you train on a very big data set, and you just change, just the top part. So you'll do some fine tuning, that is specific to your task, for example. So this is basically comparing the foundational models in the language space and then in the image space. So here you have out here, so you have GPT, Falcon 40B, Palm. So you have these foundational models, and then you have the specialized. So MedPalm is the medical fine-tuned version of Palm. That's Google's LLM. And then here you see, you have the foundational model, semi-supervised learning. So this is where you're kind of, basically you don't need to use a lot of labels. What you're going to do here is you're going to just use a training paradigm, for example, where the training, I mean, the image itself is kind of used as the output classified label, right? So suppose you have a sentence, and so you have a sentence that says chat, right? So the word starts with chat. Then what's the probability that the next word is going to be GPT? So if you train your model on corpus that is beyond, 2023, for example, then this probability is going to be very high, right? Because chat GPT started coming together only now, these two words basically together. But if you train it before then, so what you're trying to train is it's unsupervised or semi-supervised, you can say it, because you will also have some sort of labeling, some cleaning. But what you want to learn is the foundational model. Okay, so this is an example of one type of generative model. So this is like the denoising model. So what you do is you kind of add, you take your image, then you add a little bit of noise, you add a little bit of noise. So you keep going t from t0 to tn, keep adding small amount of noise, and then what you make your model learn is to basically go from noise to less noise, right? So you go back all the way and try to get this original image. So over here, right, if you think about it, there's no need for humans to label anything, right? Nobody has to really annotate this because you're going from this image, you're adding some noise, and then you're coming back out. And at the time of inference, what happens is, so at inference, right, like in generative AI, you would have seen you just type a phrase or you'll just say, generate a random image. So at that point, there is no starting image, right? So what happens there? Basically, you start from noise, right? And then there is as a parameter number of samples, and then what you do is you kind of go from noise to less noise, noise to less noise, and you keep making the model reiterate over its own output. So the first time it might go from this, this image to this image. This is still not nice. Then you do iterate again. So this is the input now, and then this will be the output. Then this is the input, this will be the output. So the more number of iterations you do, the lesser the noise will become. So this is a picture of my cat. So cat's going into this encoder. This is a convolution. Most of you will be familiar with the term convolution. So we are going from this, width height channel, which in this case is maybe 3-channel RGB. You're going from that to a smaller width height but more channels. So you keep, doing convolution operations. That is, you take a kernel, you go over the image, you do convolution operations, and what you're learning is the kernel. That's the weights, and then you get this encoding. You can finally just flatten it out, and then you decode. So this is convolution transpose. So you're going from small to big. So you're kind of diffusing the thing, and then finally you get the original image back. So this is one like this is one of the main blocks that you will see in a lot of these image generation models. Okay, going now, switching gears, going into language modeling. So here you see very simple example, right? Before large language models even came about, what was language modeling? So language modeling is basically you want to predict the probability of what word is going to come, after whatever you have. So it's like fill in the blanks. You can think of it like fill in the blanks. So you have this, the car drove into the, this is like 70%. The next line is going to be, I mean, next was going to be drive, and 30% is going to be parking, right? And then you get this big branch, and then you have algorithms that can, process all these and kind of find your highest probability path. So if you see in this example, the car drove into the driveway, right? That's the example. So this is language modeling, and large language models are basically taking a lot of this and learning all those probability distributions. And of course, it's not as simple as just this tree structure that you see here. One more basic building block in all of this, at least in the language side, is that you want to go from words to numbers, right? Because at the end of the day, your computer only understands zeros and ones. Your computer does not understand a word, right? So you need to go from word to number space, and that is basically the embedding model. So you would have heard of this term, word embeddings or word vectors, right? Many common terms that you hear nowadays. What does that exactly mean? So it's basically just taking a word and converting it into a bunch of numbers. Now you can do this in many ways, right? So suppose you have a dictionary of 10 words, that's all your language space is. Then you can say the first word is one, second word is two, third word is three, right? That is also one way of going from word to number. But over there, you don't have any semantic information because there's no relation between one and two, right? One is greater than, I mean, sorry, one is lesser than two. That is something on the numeric side. But if the word one is donkey and the word two is dog, then it doesn't make much sense, right? So in the embedding model, what you want to do is you want to again unsupervised training. Right here, you're taking large corpus of text, and you're just trying to predict the next word. So what you'll do is you'll keep taking your sentence. You'll take first five words, for example, or first six words, and then you'll say, okay, what is the next word? Try to guess the next word. So you'll keep doing that, right? You keep doing that over and over again until you kind of find that words that are similar get the same uh, vector. So what happens is here, what you can do is first you can, of course, you have to have some sort of index, right? So initially you will initialize the word to some vector, and then you train it, using some like some training paradigm. For example, guess what the next word is. And then there will be some semantic information finally in these vectors. Why? Because what you can say is that the word that was guessed by the neural network, for example, that vector should be close to the vector of the word that is actually there, right? So you're trying to match those two vectors, and then you'll see that it's learning some semantic information. Okay, this is a famous Drake meme that I put together. So here, one more fundamental block which you will hear and read a lot if you are reading papers in this domain is the transformer. So wherever you see a capital T, for example, even in Chat GPT, the T stands for transformer. So transformer models were created by research group in Google, and they are one of the fundamental blocks. And in that, one of the main pieces is something called self-attention. So what you want to do here is you want to, apart from, so embedding is just you're trying to add some semantic information. In self-attention, what you're trying to do is within the sentence, you want to add some relation between words in the sentence, right? Because at the end of the day, a sentence is a sequence. And then you take these self-attention blocks and then you put them together, and then you have multi-headed self-attention. So, I mean, we're not getting into the details of this. Uh, but basically there is a good reference that we'll share with you all, and you all can go through that. That's where I've stolen these images from also. And the main thing here is that if you see the, right, so the animal didn't cross the street because it, so the is related to it, the animal also is related to it. So it's just, it's capturing these basic, these relations within words in the sentence, and this is some sort of language understanding. So now I'm going to hand it over back to Mrudul to go over the segmentation models that we are going to try and work with today.
Hello, I'm back. So we'll talk about segment anything model. It's a it's a model developed by Facebook Research. So one concept that I wanted to talk about because it's very pertinent here is foundational models. So what happens is that as part of as models get larger and larger, there is this evolving concept of foundational models. So the idea is that these are large models which are trained on huge corpus of data, and they have this ability to impart their learning on unseen data sets. So you must have, so in coming to, for example, in case of images, it's something called ImageNet. So that is sort of a foundation model. So what happens is, for people who are ML engineers or so on, instead of uh, developing the models from scratch, they use these models as foundation. They do some transfer learning on their specific use case, and they reuse these models. So these models are called foundational models. So what SAM is trying to do, it's trying to be the foundational model for image segmentation. So that is the idea here. So well, I will encourage you guys who have the systems open connected to NAT to just open this link. It's called segmentanything.com/demo, and go into the demo section of that. So we have some samples for you here, but it will be fun if you do it, interact with it yourself. You can verify if what we are telling you is correct at least. So while you are setting it up and opening it up, I will talk a little bit about it. So as I said, it's trying to be the foundational model for image segmentation. And what is special about this, and what enables it to be actually the foundational model, is the segmentation prompt, a very big part of it. So what it can do is it can take inputs as prompts. Thank you. I can't see anything. Okay, it's back. So it can take points as input. It can take bounding boxes as input. It can take mass. It can take text. Now the caveat with text here is that Facebook has clearly mentioned that it's experimental in their paper, and the demo that you will open in your laptops will not have that yet. So that part is still not there as part of code. It's still experimental. They have talked about it in their research paper, but that's about it. So what happens is this model can take all these sort of prompts, because when you want to segment something, you want to tell what you want to segment. So there are few ways to do it. You can say it in text, you can give a bounding box, or you have to mark the edges, the contours of it, so that it can fill up the gaps of the contours. So suppose you give 4 inputs, it will nicely go over the contour of the object and give you a nice mask. And of course, image has to be the input, and you get the valid mask. Now, there are multiple ways here. Now, if you have opened the demo, uh, just show you. So here is image of our office. I have basically run it through the same demo that I'm going to show you, and you can see that it's segmenting everything automatically. So SAM actually has a bunch of modes. You can give it input in multiple ways. You can ask to segment everything for you. So I'll just quickly show you. Let's say this. So you guys can try it out. Just click on the image. While it is opening, I will verbally tell you there will be option to segment everything. Do you guys see it? How many of you see it? Have you reached that screen yet? No? Okay. I think the net is too slow. Okay. While it opens, let me just go through the other modes as well. So basically, this is in this mode. What happens is we give it as input image, and we ask it to segment everything. And in one go, it will segment out the clouds and just gives that. So that is something special which was not there earlier. Now, yeah, again, SAM has this ability to give multiple masks in case the input is sort of confusing and there can be multiple valid results. So you all have met Abhinav already. This is his image. So what I do here is that I uh, clicked on his green shirt, and what that can mean is you might want to segment Abhinav out of the image, or you might just want his shirt. So basically what SAM does is it gives us both, and both are valid results. So in case of ambiguous input, SAM has a mode to give you multiple valid outputs. Yeah, so I wanted to introduce a little bit behind the scenes what's happening apart from what you can do with the model. So if those who have tried in the website, you will see that when you click on some image, it gives you this graphic of extracting image, embedding for an image, and it takes some time. And after that, the response is quite faster. How many of you observed that? Can you please tell me? Okay, thank you. Thank you for your participation. So, and there is a very good reason for that. We'll come to. So basically, what happens is when you give it a image, the image encoder encodes it and gives output as a image embedding, and this image encoder is quite heavy. So it is basically a transformer. That's why Kashyap introduced it beforehand, because it's a very important building block for everything that is going on in the machine learning space. So this image encoder takes some time. It's not real-time performance. So that's why you see that graphic that it's loading this extracting image embeddings. And this is quite heavyweight encoder. So it gives out the image encoding. And the prompt encoder is basically what you are trying to mask out. So for me, the points were the prompts. It can be boxes, which you will see in the workshop, by the way. So the prompt way method that we are using in the actual workshop will use the bounding boxes, not the points. So for me, they were the points. So this prompt encoder is quite lightweight, and it will give it will give encoding that will be fed into the mass decoder. Now this mass decoder is very lightweight, and it's important because if you want a real-time performance out of your model, the decoder has to be fast enough. So if you're thinking that, okay, what about the image encoder is quite heavy, it's going to take a lot of time. So overall, you are not going to get a real-time performance. So what's the point of it? So the point of it is this. So consider a use case where you have your VR mask on, you're looking around in your house. Now you have been in your house every day. So it's just the first time it will encode everything out and it will just save it. And next time when you go and look around, it will just give you real-time performance. So that's a very nice use case, right? So that's why it makes sense to have a very light mass decoder, even though the image encoder is quite heavy. So I wanted to also introduce how we will use SAM in our workshop. So as I said, the prompt method that we will be using in our workshop is going to be the bounding box one. So here is some sample we have put together just to showcase what will happen. So there is another ML model that we will use in our workshop. So we will be building a compositional AI pipeline. So the idea with foundational models is also that you want them to be used in these compositional AI pipelines. So basically you put them along with some other AI models and get them in working in a pipeline. So going with the same idea, we have this another ML model which is called grounding Dino, and basically what it will do is say image object detection model. We give a tag called persons. It will try to identify persons and give you nice bounding boxes. Now the problem with SAM is this, what SAM can do is it can give you a very nice mask of the object, but it cannot tell you what that object is. So if you want to segment out a chair or a person, SAM doesn't know that. It will give you the mask, and that's fine. Very nice mask at that, but it doesn't know if you want just the mask of the person. It can't do that. It can't do identification for you. So what we do is we use this model who identifies the objects in the image, gives you nice bounding boxes and confidence scores, and since we know that SAM can take the bounding boxes as input, we use that prompt mode, give that input to the SAM model, and it gives us nice mask of all those things. So if you see on the right hand side, this is just image of our office. So you will see nice masks for chairs and humans and laptops and so on. Uh, yeah, again, it demonstrates the idea of compositionality. So this is a compositional AI pipeline that we will try to recreate in our workshop. And that's about it on SAM. So I will just, so this is actually the main part of the workshop. So you guys don't have to get bored listening to us anymore. You will get to do something. So I will just hand it over to Bishop.
Yeah, that's it. Okay, so you should have something like this opened up on your Google Colab. Uh, does anybody have this opened up? Can you please raise your hand? Okay, it's like, yeah, you have to open the attendee Pravega workshop notebook. Attendee, and if you don't, I mean, the good part about that is there's a puzzles in that, And those people who get the puzzle first, they get a Apra Labs goodie. Also, the solution is there, so don't cheat. Okay, do we have at least 50% of the people with this open? Can you raise your hands, please? Okay, no, I'll still, okay. So while people are loading, basically what we're going to do is we're going to download these models in this notebook. Models are going to be downloaded. Then if you have a webcam on your laptop, you'll be able to work with images that you can capture now live. Ooh, help. Just go keep, just check if somebody is facing issue. Please raise your hand if you have issues. Oh, network. You don't have nearby? Okay, I'm going to show this for another 30 seconds. Just take your phone and take a picture so that uh, you have it. Also, don't tell IISc we gave all the username and passwords out, okay? Okay, so if you don't have that, yeah, okay. All right, so if you don't have that, still just raise your hand. One of my colleagues will come and help you out. So going to the notebook, yeah, so we have, so Jupyter Notebook, very like good user interface. You can have these pieces, like this is all, it's the introduction, this is what we're going to do. So this image in the office, we're going to run dyno, grounding dyno. So this is basically object detection, but object detection because you don't even need to train it for one particular type of object. Then you have segmentation, and then we have in painting. So to run the notebook, what you can do is you can either press play over here, all right, or you can click on the cell and then press shift and enter. Okay, so if you press, then this is gonna, I mean, this is something I'm getting. But since you have uploaded since you have uploaded to your collab drive, you should not get that warning. Any doubts? Was anybody able to run this first cell? Zoom, okay. Is it better? Is this better? Is this too loud? After you load your drive to this Google Colab, then we're going to use GPU acceleration. So why is GPU important? Because machine learning, deep learning, and gaming. Like if you have a gaming laptop, you have a GPU, right? So most people buy a gaming laptop, but now you need a gaming laptop to like train models, uh, and all the matrix operations basically are optimized in GPUs. And in gaming also you have a lot of rendering, you have a lot of matrix operations. Similarly, in deep learning, you have a lot of matrix multiplication and matrix operation. That's why both need GPUs. So we're going to load a GPU in this. So as I said, just press play or shift enter. Then this is just getting some home directory, setting up your environment. Grounding dyno. Sorry. No, you need to give access to the. It's just going to save this notebook in your drive. That's all. Uh, so grounding, dyno, zero shot object detection. So if you see on the left, right, this is like traditional image classification. This just has a person. Here you have traditional object detection. You train the model to find guitar and person. And then here you have something called zero shot detection. So this is like, it's automatically detecting harmonica and bench. And then zero shot object detection. So here what's happening is you kind of give some cue and then it detects an image. Then something about model. You can feel free to go ahead. So this step is going to download grounding dyno. This is going to download the repository so that you have all the code in this environment to run this model. Okay. Oh, okay. So all everybody is using the internet. That's fine. So this repo is going to get downloaded. Then you can run pip install. So pip is a package manager in Python. So this is going to install anything like library. So this is by Facebook research. And again, the objective of this workshop is just to introduce you all to these, these great repositories and these models, and to just show you how easy it is, to kind of build a simple pipeline. Of course, a lot goes behind in building these models, but so again, some more installation of some environment settings. So has anybody two? No, okay. Till then, I'll fix some technical issues. No, no, it's working. It's coming. Okay, I mean, but it's different internet, right? Okay, any internet issue feedback goes to IISc, not to Apra Labs. Huh? It's just joking. This was maybe expected to happen. Yeah, sure. Notebook link is over here. Okay, anybody still at this step? You haven't downloaded the notebook? Okay, don't feel shy. Just raise your hand. Somebody. Oh, just oh, internet's bad. Who is from? Anybody can help us out with this bandwidth issue? But there's no bandwidth. I mean, I'm on which internet? Which internet am I using? So I'm also using, right? I'll be hogging their bandwidth, which is already hogged. Yeah, just we can make it face the thing. Okay, so Kushal, what's it looking like? So yes, it's downloading. Okay, cool. So those of you who have reached step 2, now what we're going to do is we're going to download the weights. So like I mentioned before, what exactly is the weight? So if you see this, right, this while everything is downloading on your PC, if you just turn your attention to this image, so this is a very simple. I mean, it's part of a SAM model. This is just the initial part. So mask input, and there's also another input node that I'm not showing here, but this is just the input image, and then the first block is the convolution block. And when we all say training, weights, learning, what are we talking about? We are actually just talking about this matrix getting the appropriate and right numbers for everything to make sense, right? So when you take this mask input image and then you run the convolution operation on it, so the convolution network, and you get some output, that output needs to make sense for the rest of the thing, right? So what are we downloading right now? We're just downloading this values that's going to sit into these in these matrices. So weights, biases, and also just the model architecture itself. So we have the model weights. If you run this step is just setting some path again. Then this one might take some time. But let's see, has anyone done this step? Download grounding dyno, Swin. Yeah? Oh, okay. Great. So the value of these weights are uploaded by the people who train them. So this is, yeah, so it's already trained. So if you see here, right, so this is their official repository, and the download section, they have alpha release, and we're just downloading the weights. So we're just going to download in this environment. I mean, later on, feel free to use this notebook however you want. You know, it's for all of you who have come in this workshop to experiment and play with. Yeah, just let people know. Mine doesn't matter. I'm not running. Okay. All right. So, how many people have downloaded this Dino weights? Hands? Okay. Okay. Few handful of people. Okay. So then, I mean, this will be the initial setup. So it might take some time, but we can still talk about what's happening here. So feel free to go to the next cells. So next, what we're going to do is we're going to download the segment anything model weights. Again, so you see this at Facebook AI public file. So this is again a model trained by Facebook, released for the public to use. You can take this, try it out, retrain it if you want. Maybe you're working in the chemical school here, and then you have something else you want to try this on, right? Some microscope images or something. So you can take this. This is your base model. It'll be a good base model, and then you can retrain on some other data, right? Or if you're working in the earth science field here, then you can train it on rocks, for example, or minerals. So till now, again, we've just been, kind of setting up the environment, downloading the models. Anybody has issues, just raise your hand. I see a lot of my colleagues not doing anything, so let's put them to work. Guys, Tin, Kabir, behind you. Okay, so what happens now that we have the weights? We're going to load the weights into the model. So what does this model thing mean? Basically, you have the model architecture, right? And then you have the weights itself. So up here, what I was showing you, this is, you can think of this as a model of architecture, right? And now we have to load the weights and so there are different deep learning frameworks out there. There's TensorFlow, there's PyTorch. All of these models, I mean, all of these frameworks have their pros and cons. Uh, you'll learn, later on. Like Google created TensorFlow and PyTorch created Facebook. So it's all like this big tech rivalry, but it's good to have, it's good that there's no monopoly. So we have the model architecture. It might be a JSON or a YAML file. So that's just going to be like, convolution followed by uh, fully connected or attention block. So that will be your architecture. It can be a JSON file that you can just look at. And then you have like your binary, which is the weights itself, right? So you can save during training, after training, and finally at the time of inference. So that's what we're doing now. We're not doing any training, but we're doing inference. We're going to use those models. At that time, all you need is the architecture and you need like a snapshot of the weights. Okay, so you need a good snapshot and then you can load that and then you can basically play around with the model. This is something that maybe whoever's interested in this domain should be familiar with. At least you should know what this stands for. This Open Neural Network Exchange. So like I was saying, right, on the left, you see all these different deep learning frameworks and they all save their models in their own way. And then, so you have, suppose you have your setup in some environment and then you want to use a model from PyTorch. It's usually when you get into this, especially with GPUs, you will be facing a lot of issues that's not really related to this deep learning stuff. It's mostly like driver issue or versioning issue that you will face. So they have developed this Onyx open interoperable framework. So you can convert from one model, I mean one type to another, and then you can just share this model. So those of you who are into training or who want to get into training models, it'll be good to know of this Onyx of this Open Neural Network Exchange, because if you want people to use your model, then it'll be nice to just convert your model to Onyx and then share it with the world. So then anybody can use that model. And here in this thing, what happens is the architecture and the weights are both in one file. So you don't have to really, worry about having any other code to reproduce the inference results. Okay, so once the weights are downloaded, this is model.load. So you're going to load the weights into the model. We're loading the grounding dyno weights and then the segmentation weights. Uh, so let me wait here. Let's see who reaches here. Whoever reaches here first gets a goodie. Ah, okay. A lot of people. Somebody do a wild guess. Okay, that was just a trial actually to make sure people are awake and listening. Goodies will come later. Okay, so if you have reached here, then you can start playing around actually, because you're not going to really use much bandwidth now. So if you have a webcam, uh, you can run this cell. So this, you'll see this big note here. So run below cell only if you have a webcam. So if you have a webcam, you can run this and take a picture of yourself. There will be a capture button here on the left top. It will give you around 5 seconds to pose. Can strike your best smile. Anybody able to capture images? Okay, awesome. So these images will be saved to your drive. What's your drive? So don't worry. Uh, those of you who don't want or don't have a webcam, don't want to take your image, you can run this cell. This is just going to be the the image that you have been seeing, like the image in our office, that very busy image. Okay, so once you have the image, we're going to do the first thing, right? So again, just so that people have time to catch up, what is the first thing that we're going to do in this pipeline? So we just captured the image. If you see this, right? So till now we were just doing setup, which is not even there in this image, in this pipeline. But we got the raw image. Now what we're going to do is we're going to segment something from that image, right? So there, what you need to do is you have to give a text prompt. You have to say what you want to segment, and then segment that so that you get like a, I mean, sorry, detect that. This is object detection. You're going to get a bounding box, and then we're going to step into segmentation. Okay, so I'm assuming some people have moved forward. So this step, if you have come to this step, then you'll have an input box over here, an input prompt, asking you to put a class. So these are some classes that we have loaded based on how today's setting is going to be. If you did not click an image on your webcam, then you can just type any class that you see in that image. That can be a person, a laptop, the ceiling, for example, and then just press enter. So here you see some parameters, right? You can play around with them later. We have set them to some level right now. So this specifies the box threshold, specifies minimum similarity score for an object. So like I was telling you, right, like in the grounding dino model, there is no class that you have trained it for. It's based on the text prompt. So whatever you type in, it's going to detect that. So that's why you have these, text threshold and box threshold to kind of, depending on your scene, you might want to play with this. Okay, so you're going to run your first model soon. You can run this step. Yeah, so after this, I think you would have ran your first model. And you should have an output that looks something like, so you should have an image that shows up with your image on the left and then like a bounding box basically. Did anybody run the Dino model? Yeah? Okay, great. Okay, cool. So if you want, you can actually just play around, like take an image of now you might take an image of your face, you can take an image of the room, just move your camera and then just see like, put different text prompts, see what all you can segment. See if you can get the fan, for example, or the projector. Okay, so you should have, okay, let me just wait. Abhinav, Abhinav. Over there behind everybody's doing.
Everybody's doing it and everybody's not doing. Some of them raised and they never completed it.
Go there only. Yeah, they're stuck. Okay, cool. Anybody has reached this step, step 8? Awesome. So now we're going to go to the next step in the pipeline. We're going to segment basically the class that you detected. So here Mrudul was telling you, right, you have many different ways to run this segmentation model. One is you can give a bounding box, you can give a coordinate. So in this, we're going to give a bounding box. And I mean, feel free to, go home later and then read through all this. We've taken a lot of hard work and kind of put all this together, all this information. So if you're interested in this computer vision domain, it'll be good to go through this. Uh, this, I'm just waiting for people. So this is like some Python code. So syntax here. So you're defining a segment function and that takes three arguments. It takes the predictor, which is the model. It takes your image, which is you see ND, so n dimensional array. And then it takes your bounding box. This is your XY. So you can call it like your, however you want to represent your bounding box. You can do center, width, height, or, top left, bottom right. Cool. So some basics in image processing. I mean, one thing is important. So color correction. So for example, you might have a sensor that captures images in a different format than what your model expects. So this is where where we showed you the pipeline, right? Apra Pipes. So again, that is a open source GitHub repository. Feel free to check it out. Basically, it's written in C++, so that it runs on embedded systems at high performance. But that has a lot of these modules built in. So color correction, very important because your sensor, your camera, for example, can give you in a different color format, and then you need to convert that, right? So many of these building blocks in computer vision that are common to all the use cases. Those modules we have written and built for people to use actually. So it's open source, free to use. And here you can see, right, the difference between BGR and RGB. And why this matters is because if your network has been trained like on a specific color format, then you want to make sure that the pre-processing steps are the same, because usually what happens is you're not actually going to give like 0 to 255, you're not going to give a number from 0 to 255 to your network. It's going to give a normalization and image before you pass it. So there is some pre-processing that you do before you pass it to your network. Okay, those of you who have done that, okay, let me check who's found the first puzzle and solved it. Okay, that's a test. Nobody's running ahead, fine. Uh, so here we're going to run the second model, right, the segmentation model. And once you run it, you should have your image with your segmented mask. So whatever object you had detected, that should be segmented. So yeah, uh, I think he's calling. Has anybody reached here? Okay, can you turn your laptop and show me your image? What you have here? Okay, nice, cool, great. So many foreheads are there. Okay, cool. So maybe you can try your cap. That will be nice. Yeah. So you put person. So yeah. So you can try and change your cap actually. That will be a fun experiment. So okay, nice. So people have segmented some images. So how do you feel like, right? You have ran two of the most recent groundbreaking models in computer vision, mostly by pressing Shift Enter. So, right, it's pretty cool. But I encourage you to go home and kind of experiment, and of course go to the depths and try to figure out what these models were trained on and why they work. Okay, cool. Now we're going to generate masks. So you got the segmentation output. So this is the first puzzle. You can't just put your hand up and don't cheat. So what you need to do is implement the function. So if you would have seen, right, you would have got meditation. So you saw your image, right? You had 3, 4 people. So what this code will do is this code is supposed to take that detection mask, all the different detections that you got, and give you only one, which has the maximum score. So let's see. I mean, try to write that function. And if you're not familiar with Python, basically just come here and the first thing you can do is just press like print detection masks. So you'll be able to see at least what exactly this is. You'll be able to see what detection mask is, and then you can try and figure out. So spend some time, and like I was saying, right, you can type your print, okay, like this print. Oh, sorry, print, and then just press detection mask. Just type detection masks. So it's going to prompt you also, you press shift enter, and then you'll have to call this function. So you define the function. Now you want to call it somewhere, right? So you can just call it here. Mask confidence. Yeah, you can call this function, and then the input should be whatever you have up here. So you have detections, right? Okay, so I've been told you just need to implement the function. Yeah, it's called here. So you can implement the function and then run this. If you want to cheat, you can show the code. Okay. Okay, those of you who could not download your weights, I think the bandwidth is now getting better because most people have done it. You can try again if you want. So we can move. Okay, goodies. Anybody has done this? Yeah, somebody there. No, no. First, you have to check whether they've really done or. Okay. So yes, you can ask 1, 2 questions. Okay, they both get goodies. Let's not make it difficult. Great. Thanks. So you're supposed to have this, right? Basically, what we did is we took the mask and we just created a black and white image. So whatever was detected, whatever segmentation was detected, that will be white, and whatever is remaining behind should be black. Okay, now the fun part. Work is all. Uh, there's one more puzzle. Okay, so import all the necessary libraries. So now we're setting up the last final part of the pipeline. I'll let people reach here, but just so that you kind of have a visual picture of where we are at. So we did this, right? You got your bounding box. Then we did segmentation, and then you filter to only keep your maximum highest probability mask. So you have your mask filter, you have your mask image, and now we're going to use stable diffusion. So this was the one where I showed you, right? The noise, slight amount of noise getting added and then denoising. So this is a model that's been trained in a similar paradigm. And then what we're going to do is we're going to say that color that mask paint something, whatever you put your prompt. So if your mask was a kid, then you can say make it a hat. But if your mask is anything you want, Gandhiji, that's what we tried. Monk. Okay, going back here. So pipeline parameters. Again, this is like some content that y'all can read later on. How are we doing on time? 3:48. So what you see here is, I'll just speak briefly about this. So you have this prompt, a dog wearing a hat, and then the tokenizer was, remember I was talking about indexing your words when you're going to word to embedding space, right? So that's your tokenizer. You're kind of going to index the words, and then you go from token to embedding, and this embedding is a vector that's learned with some semantic information in it. Then you have text embeddings, and then you have like a UNet model where you go from cat, then you go to one that's the U basically. Then you have a variational autoencoder. So this is a type of generative model, and keep doing this multiple times till you get the output image. So this one is like I think 6 GB. Yeah, around 6 GB. So you may not be able to run it on your desktop GPU if you're going to run in Python. There are the libraries you can search for stable even on CPU. So you don't even need a GPU. So if you, I mean, if we give you a feedback forms for this workshop, we'll share all these helpful, might in interest to you. Okay, I've been told I forgot a very important thing. So those of you who come successfully, okay, so I really forgot one. So we're going to pre-process the image. So here what we're doing, we're just doing some resizing. It's not rocket science. We're just resizing the image so that, because that model, uh, we want to fit it so that it will perform well. And you're out. So you should have this, and then model parameters. You can play around this. This is your. So what are you going to paint this with, right? That's the whole thing here. And at 12, who's this at 12? Okay, so okay, what are you putting? What do you want to put? What are you going to put in your prompt? Now you have to color. So you need to put a prompt. So what was your mask? Green? Just green. Okay. Green trees, okay. What's your name? Sorry? So why don't you do it on your image and then show me what you get? I just try to let's see who gets the most creative piece of artwork. Compliment from my side. Oh, this no. Okay, do you have an AI table? No, okay. So he put Messi, and his dream has come true. Now he looks like Messi. Okay, so we are going around trying different products. So here we replace the ceiling. Okay, we got one more. Virat Kohli. We have Virat Kohli also in the house. Great. So who over here Give my bottle. So a little bit more on Apra Labs. We have an office here in Bangalore, HSR layout. Next time when we host our meetup, please, watch out for it. You can come visit our office. We have these similar meetups and workshops. We also give more goodies and you also get snacks. So if you are motivated by food, then there's snacks also. And we have two other offices. So we also have an office based out of Boston and one in Dubai. So that's where I've come from. I flew in today morning actually from Dubai and came here directly to host this workshop. So thank you all for showing up in large numbers. Made it all worth it. I know what I want to ask you is the certificate thing and then the feedback. Okay, how many of you were able to do at least one sort of in painting? Can you please raise your hands? Just keep your hands up so we just know like how successful this workshop is. Okay, and did you all have fun? Yes. Okay. Awesome. So now I am going to stop talking. I encourage you to continue playing around with the notebook. We are going to now hand over some certificates, get some feedback. So I'm going to hand over to uh, Siddharth. Are you? Yeah, I'm handing over Sid. So he's going to take it over from here. Thank you again for coming and listening to me patiently.
How many people were able to run their own image?
Should I use this or I don't need this actually?
Yes.
Hey guys, hey guys, am I audible? Thank you so much for coming to this workshop. Um, what I really want is a feedback from you guys. So if you can scan this QR code, it will take you to a Google form where we are asking for feedback. Along with that, if you don't want to scan, we have also given you the feedback sheets in your book. You have to write your name. If the internet here doesn't work, you can do that, and then you can fill the actual feedback and give it to Himani outside at the registration desk. Once you give your feedback out, we will share the certificate with you. Okay? Am I clear? Clear? Everything okay? If this doesn't work, you have feedback forms on the side of pasted on the side. You can use that.